Today we discuss about the design of a sedimentation tank for primary treatment. Let's consider a numerical question to design a rectangular tank for the primary sewage treatment. Here a question: we can design a suitable rectangular tank provided with the mechanical cleaning filters. There are two types of sedimentation tanks. First one is provided with the sedimentation cleaning filters, and second one is the activated sludge treatment equipments. Here the question is directly given, provided with a mechanical cleaning filter. So we have to consider this point for the detention period. Next, for treating the sewage from a city provided with an assured public water supply system. That means a city is given and a public water supply system of maximum daily demand of 12 million liters per day is given. That means the quantity of water consumption that is given, which is 12 million liter per day. Next, assume suitable data for detention period and velocity of flow. Here there are 2 points. First one is detention period and second one is velocity of flow. To understand these 2 points, we have to first draw a sedimentation tank diagram. This one is the cross section of our sedimentation tank. Here it is inlet of wastewater here, or sewage. This one is our flow level and this one is freeboard. Here it is outlet of treated water, and this one is depth. Here it is width, depth, capital H, and width, capital V. This is the cross sectional view or side view. So detention period is the time period for which the sediment particles is contained in the sedimentation tank. That means this sediment particle contained in this tank, that time period is called as detention period. And velocity of flow is the quantity of flow, or value of velocity through which, by which the particles move from this point to this point. Next, the standard values for these things are: for velocity of flow it is 0.005 meter per second, and for detention period there are two things. When for secondary or further treatment activated sludge process is adopted, then the value of detention period will be lower, that will be 1 hour. If filters are adopted, then it will be 2 hours. Next, here this one is the freeboard. It is a difference between the higher flow level to the top surface of the tank. Now we see the top view of a tank. This one is the width and this is the length. So for the design of tank, we have to determine the values of length, width and height of the sewage in the tank. For these values, there are some standard parameters such as width should not be less than 7.5 meter. Most generally it is adopted around 6 meter, and length of the tank will be 4 to 5 times of the width. And height must be 2.4 to 3.6 meter for primary sedimentation tank, not secondary. It is for primary sedimentation tank. Now let's solve this question. These are the various parameters we have to determine for the design of a sedimentation tank for primary treatment. Next, let's solve this question. The data is given, which is quantity of water consumed by the city. That is 12 million liter per day. We assume that 80% of this quantity will convert in sewage. Let's see how much quantity of sewage will produced in the city. 80% of the consumption, and the quantity of sewage will be 0.8 into 1 to 12 mld, यानी कि 9.6 mlt. This is the quantity of sewage which is produced in a day. Secondly, let's assume the detention period is 2 hours, because here the second for the further treatments filters are provided, because the mechanical cleaning filters are provided for the secondary treatment. Now let's further move to the quantity of sludge, that is 9.6 mld. Hence the capacity of tank, we have to determine the capacity of tank. That means amount of sewage which is stored in the sedimentation tank. We have to determine the capacity of tank, which is quantity of total sludge per hour. This is given for the full day, and for the 24 hours, which is 24 hours. That means this quantity will be produced per hour, and the detention period is 2 hours. That means the capacity must of the tank must be the amount of quantity of the sewage stored for the 2 hours. It will be around 9.6 million liters, यानी कि 10 to the power 6 divided by 24 into 2, it is 80. 24 to 0.8 10 to the power 3 liters. Now converted in meter cube, that will be 800 meter cube. So volume, capacity of tank will be 800 meter cube. Now we know that volume is equal to area into length. Here, to determine the length, we have to consider to determine the length, we have to consider the velocity of flow. We have to assume, consider a velocity of flow to determine the length of tank, because length is equal to velocity into time. Now assume velocity of flow will be is, what is the maximum amount of values? It is 0.005 meter per second. It is 0.005 meter per second. And the time period is the detention time. Hence the length of tank will be 0.005. It is velocity, and time period is 2 hours. Velocity is given in meter per second, so we have to convert it in second. It is 60 into 60, which will be around 36 meter. Hence we have determined already the length of the tank is 36 meter. Now area of the tank, it is volume divided by length. It will be 800 divided by 36. It will be 22.22 meter square. Now once you have determined the area of the tank, now find the values of width and depth. Again we assume the depth of tank, we assume the effective depth, which is equal to 3 meter. This one is the capital H from this point to this point, higher flow level to the bottom of the tank. It is 3 meter. Now width is equal to area divided by depth, 22.22 divided by 3, 7.40 meter. Adopt 7.4 meter as width of the tank. Again assume the freeboard of 0.5 meter. Hence total depth will be total depth will be 3 meter plus 0.5 meter. It will be 3.5 meter. Now all the dimensions of sedimentation tank will be: length is equal to 36 meter, width it will be 7.4 meter, and depth is total depth is 3.5 meter. Now check the parameters for the standard values. First one, we have to check that depth. It must be between 2.4 to 3.6 meter effective depth. Again width must be less than 7.5 meter, and length will be 4 to 5 times. So all the parameters are correct, hence the final dimensions of the tank 36 by 7.4 by